All right, welcome to The Explainer. Today we've got a story about a revolutionary material, something born right in the middle of the Cold War. The goal? To create something totally unbreakable. And, this secret ended up changing everything from the very top of the Kremlin all the way down to your kitchen. So, let's start our story high above Moscow. See those ruby glass stars on the Kremlin towers? Back in the day, the challenge was, how do we make something that's beautiful and glowing, but also tough enough to survive the brutal Russian weather? It had to be a symbol of endurance. But what started as a project for a symbol, well, it kicked off something way bigger, a secret scientific race to completely rethink what glass could even be. So you gotta ask, right? What if the secret to making glass unbreakable was actually hiding in plain sight, in a star above the Kremlin? Well, that question takes us down this really wild path of parallel invention. You've got this quiet competition heating up between the superpowers, and the crazy part is they were each racing to create the exact same ultimate super material, pretty much without the other one knowing. Okay, so let's get into it. Here's what we're going to cover. We'll start with this big dream for an unbreakable material. Then we'll meet the two scientists who were in a race to make it happen. We're going to break down the secret science behind it all, and then follow its journey from, believe it or not, industrial waste all the way to the space race. Right, first up, the unbreakable dream. For centuries, scientists and engineers had this dream. They wanted to create a perfect hybrid material, something that had the see-through quality of glass, but the pure strength of ceramic, and none of the downsides of either. Truly the best of both worlds. Which brings us to a tale of two scientists. This is where the story gets really interesting. Let's meet the two guys who, working completely separately on opposite sides of the Iron Curtain, would somehow, almost at the exact same time, turn this dream into a real thing. So on one side, in the US, you have S. Donald Stookey at Corning, and his big breakthrough, it was a total accident. A happy accident, really. He just forgot a glass plate in a furnace that got way too hot. But then, over in the Soviet Union, you have Professor Isaak Kitaigorodskii, and his work was the complete opposite. It was a methodical, state-funded mission to create a whole new class of supermaterials, which he called Sitalls. Just look at this timeline. The 1950s were just an incredible decade for this stuff. You've got Stookey's accident in 1953, which creates something called photosensitive, but at pretty much the exact same time, Kitaigorodskii is hammering out the theory. And get this, by '59, his Sitalls is already being used in Soviet supersonic jets. The race was definitely on, even if the runners didn't really know who they were racing against. Okay, so what is the secret here? What's the science? How on earth do you take something like brittle glass and turn it into something that can stop a crack dead in its tracks? Well, the whole secret, it's all about what's happening on a microscopic level. It all comes down to a process called controlled crystallization. You see, normal glass has a really random, messy atomic structure. It's amorphous. But with this process, you actually force it to grow a super dense interlocking web of tiny, tiny crystals. And it's this brand new internal structure that gives the material its amazing strength. And this is what I find so cool. This chart really shows how these glass ceramics get the best of both worlds. They're easy to shape, just like glass, but they have the fracture resistance of a really tough ceramic. So imagine a crack starting to form, but boom, it immediately hits one of those tiny crystals and just stops. It can't go any further. And the way they do it is with this really precise two-step heating process. Think of it like a recipe. Step 1, you heat the glass up just enough to create millions of tiny seeds all through the material. They call these nuclei. Then, step 2, you crank up the heat even more. This makes crystals start growing around all those seeds, forming that incredibly strong interlocking web inside. So, while you needed these super pure materials for high-tech stuff, the Soviets, well, they had a breakthrough that was just so uniquely practical. It was resourceful, and they did it on a scale that was just mind-boggling. This is the treasure from trash part of our story. They literally figured out how to turn trash into treasure. They looked at these enormous piles of waste coming from their steel industry, and where everyone else saw a problem, they saw the perfect raw ingredient for a next-generation material. And this recipe for what they called slagsital just perfectly sums up the Soviet approach. The main ingredient? Industrial waste. Blast furnace slag. They just add a little bit of sand to get the chemistry right, and then for the secret sauce to kickstart the crystallization, they used cheap metallic sulfides. The result? a material that was tough as nails and super cheap to mass produce for everything from factory floors to the outside of buildings.
Okay, so now we've got these incredible materials, and their properties were so amazing that they started showing up everywhere, from space shuttles all the way down to cooktops. I mean, this stuff was really everywhere. It was used for radomes on supersonic jets to protect pilots. It formed the super precise mirrors for the Soviet Buran space shuttle. Back on Earth, Sitalls was being used for super durable industrial flooring. And in the West, the consumer version, called pyroceram, was probably cooking your dinner on a glass ceramic cooktop.
So why was it so good for all these high-tech things? It comes down to this number. This is its coefficient of thermal expansion, and it's basically 0. What does that mean? It means the material barely expands or contracts at all, no matter how hot or cold it gets. So whether it's in the freezing vacuum of space or getting blasted with heat, it holds its shape perfectly. And if you're building a giant telescope mirror or a guidance system for a spacecraft, that kind of stability is everything. And that brings us to the legacy. Because the thing is, the discoveries of Kitaigorodskii and Stookey, they didn't just give us a new material. They basically kicked off a whole new field of science. And their innovation left behind a legacy that, honestly, we all benefit from every single day. Just think about it for a second. The science they figured out is now fundamental. It's a huge part of modern material science. You can find it in the super tough, scratch-resistant screen on the phone in your pocket. It's in advanced medical stuff like dental implants. It's in so many technologies that need materials to be both incredibly strong and precisely engineered.
And that really gets to the heart of why this story matters, right? It's not just about some cool new material from the past. It's about a whole different way of thinking. It's about a drive to create things that were genuinely built to last, and to do it by using the most unexpected, overlooked stuff you could find.
So that leaves us with one final question to think about. We live in an age of disposable everything, right? Products that are designed to be replaced. So what can we learn from a time when the goal was to create something that was, for all intents and purposes, meant to last forever?